là maintenant on va écouter Wheat qui est Alexandre lui-même et qui va nous parler de la réponse immune et d'orientation Tsugamoshi, qui est en troisième année de thèse aussi, et va nous présenter ses travaux.
Good afternoon, every audience. Today I'm going to present my research topic on immune response to original Tsugamoshi infection, which is the causative agent of scrub typhus. Scrub typhus is a tropical disease in rural areas of Asia-Pacific regions. This endemic area is confined to the so-called Tsugamoshi triangle. You can see from the picture that the endemic area extends from the East Asia, such as Korea and Japan. China extends to the Southeast Asia and include the northern part of Australia. And in the west, it includes the South Asia, including India and Pakistan. It is caused by the bacterium Orichia Tsugamoshi, which is an intracellular bacterium that infects endothelial cells and monocyte macrophages. Scrub typhus is a common cause of acute febrile illnesses in the endemic areas. The patient with this disease can develop clinical manifestations such as fever, headache, myalgia, lymphadenopathy, maculopapular rash, and hepatosplenomegaly. However, these symptoms are not specific, and sometimes it is difficult to differentiate from other diseases. The ESK is quite specific for the disease, but is found in only 1/3 to 2/3 of the patient. In untreated patient, the patient can develop complications such as meningoencephalitis, interstitial pneumonitis, hepatic dysfunction, myocarditis, and renal failure, and eventually multi-organ failure and death. The definitive diagnosis is made by immunofluorescence that detects the phosphorizing of antibody or IgM antibody. This picture shows the life cycle of a Rectochlamydium larva, which is the vector of scrub typhus. You can see that the larva of the mice is the ectoparasite of the mammals, including humans and rodents, whereas the adult mite is a free-living insect that lives in the soil or on the ground. After feeding the blood of the human or the rodents, the larva develop into nymph stage at adult, and then adult can pass the organism by ovarian transmission to the egg and the larva, and the larva infect the humans. For the bacterium Orichia Tsugamoshi is an obligate intracellular bacterium. It was classified as a new genus that is distinct from Rickettsia. It can invade a variety of cell types. In this picture, in endothelial cells, in skin and visceral organs, and in macrophage, in lymph node, and in Kupffer cell in liver, and sometimes in severe case, it can be found in cardiac muscle and renal tubular cell, leading to the severe complications as I mentioned before. This page summarizes some differences between Orichia and Rickettsia. For the phenotypic difference, the cell wall structure, Orichia has no peptidoglycan and LPS in its cell wall, thus making it fragile and very unstable in extracellular environment, and it must be stained by Giemsa stain, not Gimenez. And the membrane protein is composed of several membrane proteins with different molecular weights. For genotypic difference, there are some differences between 16S RNA sequence between Orichia and Rickettsia. Complete genome sequences of Orichia reveal several amplified repetitive sequences, including the gene for typhoid secretion system. which is quite striking. Now I will present my publication on Origin system simulate an original gene expression program in monocyte, relationship with gene expression in patients with scrub typhus that was accepted in past neglected tropical diseases. The objective of our study is to determine the intracellular phase of origin in monocytes. Secondly, to characterize the transcriptional response of monocyte to origin. And finally, we also analyze the transcriptional response of patients with scrub typhus. This diagram shows material and method. PBMC exploration was performed by focal hybrid density gradient centrifugation. After that, the monocytes were left adhere on polystyrene plate. The cells were infected with Origin strain cardo, an average of 10 to 20 bacteria per cell. And the growth of bacteria was studied by real-time the transcriptional profile by microarray and RT-PCR and ELISA secret was due to study cytokine secretion, and cell race was studied by Touré assay. This picture shows that origin can replicate in monocyte. The number of bacteria steadily increased during the 5-day experiment, and by immunofluorescence you can see that origin replicate and form the microcolony in monocyte. And from this picture we can conclude that origin can replicate in human monocyte. From microarray result, at 8 hours post-infection we found 4,700 total modulated genes, which are about 2,300 upregulated and downregulated genes. We then classified the modulated genes into different geocategories. The left one, so upregulated genes. You can see that geo-term enrichment in upregulated genes is high, about 20 to 30%. The highest geo-term enrichment was observed in gene belonging to immune response to virus. About 40% of genes were upregulated. For the downregulated gene, the geo-term enrichment is lower, about 5 to 10% of the genes in this category were downregulated. So we then explore in more details in gene response to virus and immune and inflammatory response. This table showed the genes that are involved in immune response to virus. You can see that interferon beta and some subtypes of interferon alpha were highly upregulated in response to origin. The other is such as interferon-induced protein and MX1, MX2, and OAS, which are considered interferon-stimulated genes, were also upregulated. And the expression of this gene was confirmed by RT-PCR at 8 hours and 24 hours post-infection. You can see that the expression of this gene was persistent at 8 and 24 hours post-infection, although the level may be slightly decreased at a late time point at 24 hours. And next, we want to determine if type 1 interferon response was specific to live bacteria in the cytosol. Then the monocytes were infected with either live or heat-killed bacteria. And RT-PCR of interferon-stimulated genes and interferon beta secretion was studied by ELISA. The results show that only live bacteria can induce interferon beta expression and secretion, and the expression of interferon stimulator genes such as MX1 and CXCL10 and 11. So we can interpret that type 1 interferon response is specific to live bacteria in the cytosol. Then we analyze the inflammatory response induced by Orichiaceous gamashi. Since macrophages are known to be polarized toward classically activated M1 phenotype, which is inflammatory and promote type 1 immune response. Alternatively, macrophages can be polarized toward M2 phenotype, which is regulatory and act as immunomodulator. So the question is that infected monocytes were polarized toward M1 or M2 profile. So then we compared our transcriptome with the previous transcriptome that were previously published in the paper. And you can see that most of M1 genes such as IL-12, IL-23, which promote Th1 and Th17, were highly upregulated for the chemokine CCL3, 4, 5, and CXCL10, 11, which are known to attract the lymphocyte and macrophage into the tissue with inflammation. Were also highly upregulated. For the M2 genes, most of the M2 genes except IL-1, RN, and CCL1 will remain unchanged or down-modulated. So we can conclude that Orichiaceous gamashi polarized the monocyte toward the M1 phenotype, which is highly inflammatory. So conclusion, Orichiaceous gamashi induced the polarization of monocyte toward an M1 profile. So the next question is this program specific to Orichiaceous gamashi? As I showed you that Orichiaceous gamashi induced the expression of M1 and interferon-related genes, we then compare the programs of monocyte induced by Orichia and interferon gamma. The results show that although most genes, about 80%, were commonly upregulated by Orichia and interferon gamma, however, Orichiaceous gamashi induced a specific transcriptional program. As you can see from the clustering analysis, that there are some differences between M1 monocyte induced by IFN gamma and Orichia. So then we then explore in more detail about the inflammatory response induced by Orichia. From the graph you can see that both live and heat cube bacteria can induce the inflammatory response from the monocyte, but live Orichia can induce a higher response than heat cube bacteria. So we can interpret that live bacteria are required to induce a full response from the infected monocyte. And TNF secretion was confirmed by ELISA. In conclusion, Orichiaceous gamashi induced type 1 interferon and inflammatory response in human monocytes. A recent evidence showed that cytosolic bacteria such as Listeria and Francisella can induce type 1 interferon, inflammatory response, and cascade 1 activation, which is associated with cell death and IL-1 beta release.